Earth's rotation. So what is the Earth's rotation? The Earth's rotation, or Earth's spin, is the rotation of planet Earth around its own axis. The Earth rotates eastward in prograde motion. As viewed from the North Pole star Polaris, the Earth turns counterclockwise. The Earth rotates in about 24 hours with respect to the Sun, but once in every 23 hours, 53 minutes, and 4 seconds with respect to the other distant stars. Although according to some studies, the Earth's rotation is slowly slowing slightly with time, thus a day was shorter in the past. How does the Earth rotate? The Earth spins around its axis, which is an imaginary line that runs through the planet from the North Pole to the South Pole, just like how a spinning top spins around its spindle. The spinning movement is called the Earth's rotation. The Earth doesn't only spin on its axis, it also orbits or revolves around the Sun, and this movement is called the revolution. The Earth takes 365.25 rotation in order to make one revolution. And one revolution is equivalent to 1 year. What are the effects of the Earth's rotation? The first one is the diurnal cycle. In this cycle, half the Earth is illuminated while half is dark. This causes the day-night cycle, which also creates our corresponding cycle of temperature and humidity. The second one is tides. It is the twice daily rise and fall of sea level. Tides are the result of both the gravity of the moon and the gravity of the sun. Sometimes the sun and the moon are lined up with the earth, but most of the time they are not. Tides are the highest when the earth, sun, and moon are in a straight line. The third effect is the Coriolis force. The Earth's rotation causes a deflection of ocean and air currents. The Earth rotates much faster than the winds or currents move. This causes a large deflection in the direction that winds move, and ultimately results in rotation around low pressure cells and high pressure cells. It also causes large rotating pools of water in the ocean called gyres. The Coriolis force only operates on large features or things that move a considerable distance, generally greater than 300 miles. It is also important in the formation of cyclonic weather systems. It is a general misconception that whirlpools and tornadoes are affected by Coriolis force because they spin, but the truth is they are too small to be affected by that Coriolis force because, as stated earlier, Coriolis force generally affect those that move greater than 300 miles. What is the importance of the Earth's rotation? Because of the speed of rotation, which is 1,670 km/h, centrifugal force is created, which leads to the flattening of the Earth at poles and bulging at the center. The Earth's rotation affects the movement of water in the oceans. The tides are deflected due to the rotation, and the speed of rotation also affects the movement of the wind. So what would happen if the Earth stopped rotating? At the equator, the Earth's rotational motion is at its fastest, about 1,000 miles an hour. And if that motion suddenly stopped, the momentum would send things flying eastward, moving rocks in ocean, which would trigger earthquakes and tsunamis. The still moving atmosphere would also scar landscapes. And finally, why does the Earth rotate? The Earth keeps spinning because it was born spinning. This was said by an a scientist named Nicholas Luhmann.